Hello everyone, welcome back to my 30 days embedded system learning journey. Today we are going to learn about interrupts. Interrupts are used in every industry of embedded systems. By the end of the video, you will clearly understand how interrupt works internally and why industries rely heavily on them. So, the topic is interrupt. Let's take an example. Assume you are studying. So you would be continuously studying for a certain amount of time. You might get a call, let's say your friend. You pick the call, you complete the task, and return back to your work. This is an interrupt. An interrupt is a signal, it's a temporary signal. So interrupt is a signal which stops the main program for a short amount of time. The main program would be paused until the interrupt would be completed. After handling the interrupt, it would return back to the main program. So why it's required? Before interrupts, there was a system called polling. So as we taken the example of you are studying, in the same case, this polling system would look like when you are studying, you would be frequently checking for calls or text and notifications that is any event has been occurred or not. The frequent verification for a task to be done is called polling. Polling is a very disturbing and delay task. It wastes CPU's processing time, consumes more power, and slow response for events. And it also affects multitasking. So let us understand the internal working of an interrupt. How does it work? The interrupt. So let's say you have pressed a button. That's the first step of an interrupt, where there would be tasks like button is pressed or a sensor detection, timer overflow, and data could be received from an module. So the next stage would be the microcontroller would flag the interrupt, like it notifies that there is been a task which is been arrived or pending. The step 3 is interrupt enable checking. So the microcontroller needs to verify that is the interrupt present or not. It checks for two conditions. One is global interrupt and the local or an individual interrupt. So global, let's understand global with an example. Say your mobile phone is on silent mode, and local interrupt would be like you have paused notifications from an particular application. When these both conditions are verified, then it uh, verifies that interrupt is present. And the fourth would be context saving. So before execution of this interrupt, the microcontroller saves the current program or the main program. It registers the values and program status would also be registered. This is called context saving. And step 5 is ISR execution. Here ISR refers, so ISR execution, ISR refers to interrupt service routine. It's like an emergency function. It handles the interrupt. So sixth would be interrupt vector table. So every interrupt has an address or a memory specific location which is known as interrupt vector table specific location for interrupt. So the step 7, after completing this interrupt execution, it would return to the main microcontroller. It returns, that's the final step out there. So there are some technical terminologies which we need to know about. So the first is interrupt latency. So what's interrupt latency? It's the time taken between event occurrence to returning to the main execution or ISR execution. So lower latency is preferred in the industrial cases, and the interrupt priority. The higher priority is chosen rather among lower priority one. So let's take with an example. During an emergency, a buzzer has the higher priority rather than the LED blinking. And third is nested interrupt. In this, we can say that a higher priority interrupt dominates the lower priority. Let's take an example. You are writing code in a system and there is power off. The higher priority would be like saving the program and turning off the system. And there are certain design rules for ISR, interrupt service routine design rules. They are that code should be short and avoid delay functions in it, and avoid heavy calculations, and continuous printing of values, and only execute or trigger events or flags. So the longer the ISR, the delay the system. So let's apply to an Arduino concept and verify it for the industrial cases. Generally in Arduino boards where interrupt pins are used, external pins will be used for interrupts. These are connected using an attach interrupt function. This is the main thing here. We are using external interrupts. So that syntax for external interrupt for an Arduino is attach interrupt. Here I is capital, make sure. So these can be triggered on some signal changes also. So the rising edge and falling edge, and any change in the triggering. And there are problem which is termed as button bouncing, Here, when a button is pressed, the metal inside the materials inside vibrate continuously and provides a signal which is continuous and difficult to be understand for the microcontroller, which makes the system to notice there are multiple interrupts for a single press. This is called an button bounce. To overcome this, we use button debounce concept. It detects these multiple signals and combine them to form as single function, either the on or an off state. This it can be implemented using software. In case of hardware, we use capacitors to overcome the problem. Capacitors would be used. So interrupts save the power for MCUs. So let's say an MCU is in normal condition. When an interrupt is triggered, then the system gets active and work on the particular interrupt flag, so which saves the battery and efficiency of the microcontroller. This is very important for battery optimized devices like wearables or IoT sensors. So real industry applications. These should be looking like, we can observe them in automotive braking systems and smart doors and industrial automations and communication protocols. So let us understand with an simple example. Assume a smart door lock. So this generally stays in the low power mode, but when we press the passcode, it sends an interrupt flag to it. If it's correct, the lock would be open. And that's it for this video. We have learned what are interrupts and polling versus interrupts and working of interrupts, interrupt vector table, interrupt latency and priority, and we have come across ISR design rules. And button bouncing and debouncing. And how would we interrupt this in an Arduino, and how interrupts help with power saving, and some industry level applications. So that's it for day 6. If you are also learning embedded systems, follow this journey with me, and we are going to continue some interesting topics in the upcoming sessions. Till then, keep learning and have a nice day.